Welcome to section 3 on variation. In section 2, we looked at both direct and inverse variation. Then in section 1, we dealt with the definition of direct, inverse, joint and partial, and how to solve each one of them. Now in section 3, let's look at this question. If P varies directly as Q and inversely as the square root of R, when P is equals to 5, Q equals to 2, and R equals to 16, find the value of P when Q is 10 and R equals to 5. What's the first thing we do? We have to analyze the question first. And then looking at this question directly, in section 1, we were told that anytime you have directly and inverse at the same time, what is the type of variation? This is joint variation. Very good. So if P varies directly as Q and inversely as the square root of R. So we have three things that are looking at here. Also square roots. So let's bring them out in terms. P varies directly as Q, we've dealt with this before, and inversely as the square root of R. That's the basis. Now the next thing is to remove the sign of proportionality. And how can we remove this sign of proportionality? Is to introduce a constant. We dealt with this in first section and second section very well. That becomes KQ over R, where P from the question is 5 equals K is a constant of proportionality, where Q is 2 and R is square root of 16. Remember, this is square root of 16. Now let's solve this. It seems you are saying 5 equals 2 times K, that gives us 2K, and the square root of 16 is 4. So if you cross multiply, you will be getting 2K times 1, that gives us 2K, equals 5 times 4, that is 20. So what are we going to do? Divide both sides by the coefficient of K, and that is 2. Divide by 2. So that 2 cancel 2. So that my K, the constant of proportionality, becomes 10. So K is 10. So having known 10, we can therefore calculate the law that connects them together. So the law that connects them together will be found here. And that becomes what? P equals K is 10 Q over square root of R. So this is the law that connects them together. Now what does the question say? Find the value of P when Q is 10 and R is 5. There is no way you can get this value without passing through the law, the formula, or the relationship which we have found. So P we are looking for equals 10 times Q. In this case, Q is now 10 and R is now 25. So what do you think this will be? 10 times 10. What is the root of 25? That is 5. So we can therefore cut quickly, and that becomes 5 here 1, 5 here 2. So P becomes 10 times 2, and that is 20. Therefore, P is 20 when Q is 10 and R equals to 25. See you in section 4.